morning, students. Next we are going to discuss about of compiler versus cross compiler. So up to this section we learned about of what is C and how it will be going to be implementing any one of the program, and what are the difference between when you are writing a program in C and embedded C. So now we would like to compare the compilers. I have two compilers. One compiler will support for C programming and one more compiler will support for embedded C programming. Have a look. What is compiler and what is cross compiler, and how the statements are going to be executing in compiler and how the statements are going to be executing in cross compiler, and what is the basic principles in between these compilers and cross compilers. So first one, so compiler is also a software because it is always compiling program, because it is always compiling program only. So program is a software data. It's not hardware, it's not physically available data, it's a software data, which is a data available, and we need to write a program in compiling mode, editor window, and on that it has to compile and find the errors. So when you are using a normal compiler, first the code which that you have written in compiling, whether it may be in high level language or maybe in assembly level language. Previously we have learned about this one, right? So these code, whichever it may be the code that it has been written in high level or assembly level language, this can be converted into machine level language. That is the primary principle of any compiler will work. That's the working principle of a compiler, right? So compiler is a software that converts the code written in high level language to machine level language. So whichever it may be the code that you have written in high level language or assembly level language, that code has been converted into machine level language, because it has to understand first and then only it will give the corresponding output. While it is coming to cross compiler, first it has to execute in one environment. Means for embedded C, what we are doing, writing a program. First, initially I have writing a program. I need to check whether the program having zero output errors, and zero warnings. I have to check whether this particular program having zero errors and zero warnings. If both these two conditions are satisfied, how I will check? I need to go to check by using compiler only, right? I need to check in compiler only. Compiler is always a software. So by using software, I just write in one program, and the corresponding program's output has been checked whether that particular program having zero errors and zero warnings or not. So I have compiled the program, I got zero errors and zero warnings. Then I am ready to dump this program. This program then converted is nothing but send to hardware, dumping to hardware. Once you send the program to hardware, then you can't able to do any simulations in hardware, because hardware will not support to simulate any program. Only software will simulate. There you need to debug, right? This is debug. So you need to check whether the compiler given one output now, which is having zero errors and zero warnings. This output will be an input for this hardware, and then in hardware I need to check or debug whether the errors and warnings are zero or not. If it is zero, and the corresponding hardware output will come with 100% efficiency. If not, you have one error or one warning, either maybe an error or maybe a warning. Sometimes warnings may be considered, but errors will never be considered to be as withheld. So whenever you have 1 error or 1 warning, then this output efficiency percentage will be reduced to 70%, or simply whichever the output that you are expecting, that will not be executed over there itself. If it is a compiler, it will implement only in software only. If it is a cross compiler, First it has to generate and check in one environment and gets the code into the another environment. That's what exactly that you are doing. Whenever you're writing a program in software, first initially in one environment that you're executing. Software, you're writing a program and checking the output whether it's properly executed or not. And then you are sending that code to hardware, and there also you are checking whether it's properly working or not. That's cross compiling. Compiling is nothing but finding errors and checking errors. Cross compiling means even it may be compiled and giving outputs and errors and warnings as 0 also, whether it is properly working in hardware or not. It has to check, cross check. And most of the time compilers are used in Windows platform to create the application that are run on the Windows platform only. So Windows platform is nothing but Windows. It's just an operating system. In operating system of either it may be a PC or it may be a laptop. So without having OS, we can't able to install any compilers. Not only compilers, any softwares. Even you can't able to store one data in that particular system or PC or laptop also, because without OS, any one of the PC or laptop is just one memory element, just like our pen drive. If any one of the memory element with OS, then it can be used as any one of the interfacing device. Without having that one, you can't able to use this. So now you need to compare the two compilers and cross compilers. Translates program for same hardware because it won't do any cross check. So translates program for same hardware, whichever it is. Whenever you will check any one of the software errors, so when I am checking any errors, I'll got 0 errors. At the same time, I'll got 0 warnings. Okay, that's enough. No need to go for cross checking, or no need to going to dump into any one of the hardware. So which are the softwares that you are using? First one is Turbo C, and one more is CPP, which will support for C++. So anyhow, you can remember Turbo C, that's enough. So Turbo C is a software which will compile the program and gives the errors and warnings only. It can't handle any hardware. While it is coming to cross compiler, it will translate the program in different hardwares, because initially it is checking in software. If the software output is received with 0 errors and 0 warnings, then this entire output will becomes an input for hardware. And here also I need to execute output with 100% of efficiency. Then I'll satisfy myself, yes, cross compile is working in different hardwares. While it is coming to C, it will work for only one different hardware only. And next one is, it is used to make the program for same hardware and OS it is installed on. So simply I have one PC, my personal computer, which is a system. So having Windows as my operating system, right? So I have one PC which is having Windows as my operating system. So I have a PC, hardware is, so I'll use i3 processor. So having 8 GB RAM and having 1 TB hard disk, right? So in this same PC, I have installed Turbo C. It's my software which will implement or compile any one of the C programming programs, C language programs. So then this particular compiler or else Turbo C compiler can be executed, which are the data available with this 1 TB hard disk, and by using this i3 processor and 8 GB RAM only. It can't able to handle the next or any sequential or following hardware which is connected towards to this compiler. It can't able to handle it. But while it is coming to cross compiler, it's always how many hardwares that you can connect. Okay, no problem, I'll take care of those things. It will be like that only. It will never having any problem to handle software along with hardwares. Means compiler always bother about of hardware. So it is a dependent on hardware and operating systems also. Because if I am not giving Windows as my operating system, if for example in spite of Windows I'll go for Linux, whether it will support to independent compilers? No, it won't support. So it has to bother about of OS and it has to bother about of the hardware which is available. But for that, no, I don't want to bother about of. I just need one program supported OS. That's one. So I just need one OS operating systems, whether it may be Red Hat or it may be Ubuntu or it may be Linux or it may be Windows, whatever it is. I need one OS to compile my program. After completion of compilation, the output of that particular program has to be converted to or sended to hardware as input signal. So whether it may be a 1 or 2 or 3, how many sequential hardwares are available, you can connect in series. I don't want to bother about of that. So if it is connected to with my system, then I will operate all the systems and I will check the final output. That's cross compiler capabilities. So whenever you are writing any one of the program in C language, then the corresponding output file will be in .exe. So .exe is nothing but executable file. So can be using only in compilers only. But if it is a cross compiler, whichever it may be the code, that will be available in .hex. That will be stored in cross compilers. So I already told you, it has compiler having two types of compilers are available. First one is Turbo C and next one is C++. That is green cell C++ is the native components for this CPP, and for this Keel and green call is two compilers, cross compilers. Thank you.